Okay, so now let's go over the other important way to find the torque. So it turns out there's another good equation for torque. The other equation for torque is that the torque is F times R perpendicular. We could also say that the torque is F times R perpendicular. R perpendicular is the component of R that's perpendicular to F. Or let me write that out a little bit.
So your F in this one is not a magnitude?
Nope, I should have put in that dot.
Oh, it is.
Thank you. Alright, now what is R perpendicular? R perpendicular is a line that goes from the pivot perpendicular to the line of the force. So R perpendicular goes from the pivot, and it is perpendicular to the line of the force. R perpendicular is a line that goes from the pivot perpendicular to the line of the force.
Okay.
So that would be...
It's kind of breaking up just a little. Okay, now I see it.
That would be our new step 3. Step 4 we can now skip, and the other steps will be the same as before. So we'll go through an example to see how to do this.
Okay.
All right, do you have that in your notes?
Yes.
Okay.
Is that 3 kilograms?
Sorry, 8 kilograms.
Okay.
We can call this 3 kilograms. Four kilograms. Okay. Okay. You have that picture in your notes?
Yeah, I'm almost finished. So you just drew a different distance from the end of the box to the pivot on the left, and then a different distance from the pivot then to the box on the right. Okay.
All right, one sec.
And that's like center to center, right?
Yes, that's
like
right. That's a good point. Okay. So let's go ahead and see how to calculate the torques that we would need in this case. So one point here is that in this case, we're going to treat this whole thing as one combined object. So there's a 4 kilogram mass, a 3 kilogram mass, and the teeter-totter is 8 kilograms. We're going to treat it just as one combined object that has the masses in different places. All right. Okay. So, and let's figure out what the torques are on this object. And I'm going to use our second method. So remember, the first step here is step 1, draw the forces. So can you tell me what's one of the forces on this combined object? What's one of the forces on this combined object?
You have the forces of the kilograms, the 4 kilogram and the 3 kilogram.
All right, let's pick that 3 kilograms.
On the seesaw.
So what can you tell me about the force on the 3 kilogram object?
It's going straight down.
Yeah, what's the name of that force?
It's the weight.
The weight, that's right. So we have the weight of the 3 kilogram object. That's right. Now what...
So would it be mg?
That's right.
Or not?
That's right. The weight is mg. That's good. Now, one thing we have to be careful about now, I should have mentioned this when I went through our approach, every time you draw the force now, you have to draw the point of application of the force. We need to know where the force is being applied. So where is that weight being applied, do you think? Where should I draw that force vector from that weight on the 3 kilogram object?
It's being applied down, perpendicular to the seesaw.
Okay, good. Now let's be a little bit more precise about what that point of application is. I actually didn't quite explain this before, but we can generally assume that the weight is being applied at the center of an object. The weight is applied at the center of mass of the object, and usually we can assume that that's just the center of the object. So we can assume that the weight is being applied at the center. So let me erase the fact that this is 3 kilograms here. So the weight would be being applied over here. That's where our weight is being applied. Okay, so that's where that weight is being applied. All right, now let's figure out what the torque is going to be from this over here. I'm going to draw actually a whole new picture here.
Okay.
All right, here's the weight. All right. So we've done step 1. We've identified that force. Ready to keep going? Okay.
Yeah.
Now, what's our step 2?
So our next step, identify the pivot.
That's right. Where is the pivot?
And the pivot is on the left there, where the triangle is.
Where the triangle is. That's right. So I'll draw in a nice big dot for that pivot. This is the point we're going to be rotating around.
Uh-huh.
All right.
Let me ask you this real quick, Stephen. Why did we start with the 3? Does it matter? Is that relevant?
No, it doesn't matter. You can start with any of the forces. So we just picked that arbitrarily.
Okay.
Okay.
All right, now what's the next step now? Now, we're not going to use this left-hand method. We're going to use the right-hand method. So what's the next step now?
The third step is going to be to draw your perpendicular, your R perpendicular.
Right, and now remember, where does that start?
That starts at the line that goes from the pivot.
And it goes perpendicular to the line of the force.
That's perpendicular to the line of the force.
Now, I haven't actually drawn any R perpendiculars for you yet, so let me just show you what that would look like here. So here's what the R perpendicular would look like.
Okay.
Can you see how this starts at the pivot, and it's pointing perpendicular to the line of the force?
Yes.
Okay. Now notice that this is, alright, so that's what that R perpendicular means. It's a line that goes from the pivot and then perpendicular to the line of the force. So you can see why it's called R perpendicular. What is it perpendicular to? It's perpendicular to the line of the force.
Okay.
Alright. Now, one thing to notice is this is not the R vector. right? I'm going to draw in the r vector here. The r vector would look like this, wouldn't it? Because the r vector goes from the pivot to the point of application of the force. Well, remember the force was being applied at the center of the mass. So the r vector would be looking like this at a diagonal, from the center to the point of application of the force. R perpendicular can kind of be easier because that just goes from the center to the line of the force. Do you see the difference here between r and r perpendicular?
Yeah.
Okay.
Okay, yes, so our line, it goes from the pivot and is perpendicular to the line of the force.
That's r perpendicular. That's right.
That's r perpendicular, and then r is going to be from the pivot to the
point of the force.
Of application.
Right. And here the point of the force. Yeah, the point of application of the force. And where's the force being applied here? Well, it's being applied at the center of mass of the object.